Hello Precalculus student, this video is for chapter 4.3, part 1, Logarithmic function. So we're going to introduce a new function called log function. So what is a log function? The basic idea of the log function is it is the inverse of the exponential function. So in the exponential function, if we look at the function notation, we say our input is in the exponent. You specify your exponent, you do a base, use the exponent to do the repeat multiplication, and you have the function, you have the y value b of x, right? So you do the exponent on it using whatever base that you have chosen. So it could be 2, it could be 5. So different base would have a different function. So this is called the exponential function. The original f is the exponential function. The inverse would be getting the b of x, the answer of the exponent, and use the log function. Now, log function would always associate with the original base, and we name it as log base b, so that the input is the b of x, which is the y, and the output is the original exponent. So, so this is how we understand it. So if I have y equal to b of x, where x is the input of the original exponential function, y is the output, then or we like to have the input on this side. B of x is equal to y, kind of like x go to y for the exponential function. Then the log function would be a new function. The formula is log base b. Now notice log base b is a name, okay? It's just the name of the function, whereas my input is y, right? My input is y, and then my output is x. So log base b y is equal to x, and this is the log function. So you always take whatever that you have as the answer in the exponent, put it as the input for log, and then whatever that was in the exponent, that is the output of the log function. And of course, when we do a function, we don't use y as the input, so we would rewrite it as log base b x is equal to y is the general log function. This is the mean. This is how it associates with the exponential function, but in general, this is the general log function. But we have to recognize that x input to log actually was a b of something, was the y of the exponential function, and then the answer is actually the exponent. So the answer of the log is an exponent. So every single base would have a exponential function. It would have a log function. So for example, consider the exponential function f of x equal to 2 to the x. Then the inverse, we use the inverse notation. The inverse is log base 2x. We use x as the input, but this input actually is the answer, is 2 to the x. Okay, so you can think of it as x, use 2 to the x, go to 2 to the x, right? Go to the use the exponential, and then 2 to the x, if you use a log, if you have 2, 4, 8, 16, all those things, it would go back to x, log base 2. Okay. And remember, log base 2, the 2 part is not part of the input, is the name, is part of the name. And when you write log base 2x, this is not an exponent. Okay. So we would, a good example would be 2 to the 5 equal to 32. But if I put log base 2, put the 32 inside the log, it would equal to 5. Okay. Because what happened is I would have 5. If I do the exponential function, I do 2 to the 5 equal to 32. But if I do log base 2, I put 32 into it, I will have 5. Okay, so we will say log base 2 32 is equal to 5 because the original function has input 5, output 2. The log function has input 32, the output is 5. So in general, we can have this kind of a form equation rewrite. If I write something called b to the x equal to y, I can write log base b y equal to x. So understand log is related to the exponential of the same base. So and then there's two other log function that we want to pay attention to, where the base is e. We call it the natural log, and we shorthand it as ln x. We don't write the base anymore. It is understood to have base e. So the base, it still have a base, it's base e, but we just don't write it. If it's log base 10, then it's long as common log and is written as logx. So you will see these ln and log in your scientific calculator. So it's not that they don't have a base, but this is base 10. It is understood to be base 10 that we don't write it. Kind of like when we do square root, we don't write a small 2 at the corner of the root. Okay, so we use this the relationship between exponential and log to rewrite a log as an exponent. Okay, so if someone write log 381 equal to 4, what is the equivalent exponential function? So exponential, we look at the base. Oh, this is for base 3, and their output is 4. My input would be 4, and it's equal to their input 81, right? Log base half, so I would immediately write 1/2 to the base. And what is their output? Their output is -3, but that would be my input. So you can see that they switch input and output. Okay, so log mx equal to k, I would say this is base m, so m is my base, and I'm doing what exponent? It was k exponent, and then the answer is the input of the log, which is x. Just keep on thinking the input and output switch. Okay, so if I do log, what base do I have? If I have to rewrite it, it's base 10, right? Base 10, my input has to be their output. G is equal to T, right? This is the log's input, log of something, so that would be the exponent's output. What about ln? ln's base is e, right? Base e, and then my exponent is the output of the log function t, and then my output is the input, which is 8. You just think of they switch input and output. We have all these exponential notation now. I want to change it into log. So I have to look at the base. This is base 8, so I automatically write base 8. What is the input? The input is not 3. I would use their output. It's 512, and it's equal to the output, to the input 3. Input, output. This is input, output, right? So let's say this is input and this is output. So I would do log base, what is the base? Base 36, right? And so this is the exponent's input. This is their output. So I would use 6 as the output, and this is 1/2. Sometimes people do it this way. They would write the log and then get the base, which is b, and then they would go to the other side, which is the output, which is p, and then go back to the input, which is 7. So you start up with the base, go to the output, and go back input. So this one you would say is base e, so I use ln. ln, the input is the output. The output is the input, a. Okay. And the log base 10 is, I use log, right? What's the input? The input is the exponent's output. Log base s equal to w. Last one, b to the 0, whatever base it is, must be 1, right? So if I do a log base, so this is the base, you start up with the base, log base b, and I use their output, which is 1. and that's the input. So remember this, any log of 1 is equal to 0. So that's how you rewrite it, and the rewriting process actually helped you to evaluate log. Okay, so far we know how to do like 2 to the 4, 2 to the 5, or 16 to the 1/2. We know how to do exponent, but how do I evaluate log? Because if I have a function, of course I want to evaluate. Now these are done without calculator, so by rewriting. So what happened is we have log 216 equal to a number. So let's say this is y. So this is the output. So corresponds to the original function is original exponential function is 2 to the y is equal to 16. So you think 2 to the what exponent would give me 16? 2 to the 4, right? Because I know that 2 times 2 times 2 times 2 is equal to 16. So 2 to the 4 equal to 16. So I say log 216 equal to 4. Let's say this is equal to y. Log 10, 100. So that means 10 to the power, this exponent must equal to 100. So what power would give me 100? 2. So when you're evaluating log 10 of something, you think about 10 to the what power would give this answer. Okay, so log 7, 17. So let's say I don't know what it is. I say y or question mark. So and then you think 7 to this exponent must be equal to 17. So how do I rewrite 17? I can rewrite 17 as 7 to the negative 1, right? So that is the answer is negative 1. D, log base 2, 1/8. So I would say, I don't know what this equal to, but I know 2 to the y would equal to 1/8. Now, we know 2/3 is 8, but 1/8 means what? Negative 3, right? Negative means 1 over, so this is negative 3. So you have to like do the kind of like the solve the exponential equation. Think of 7 to the what equal to a number, or base to the what equal to a number. So the same here. So I know that it is equal to y such that 5 to this y was equal to square root y. Square root 5. Okay, square root 5. Square root 5 actually can be written as what? As 5 to the what? Square root 5. It's 5 to the 1/2, right? Root is like a fraction. So that means this is equal to 1/2. And this would be, I would think, what base is it? It's e. E to the what? Equal to e to the 3, of course. It's equal to 3, right? There's only one way. Log 1 is always what? Always 0. No matter what it is. Or if you want to think, you would say 10 to the what equal to 1. 10 to the 0 is equal to 1. So so that's all for like what's the meaning of the exponential function and how to evaluate the log function. What is the meaning of a log function in relation to being an inverse of an exponential function? They comes in pairs, and also how to evaluate them, and also rewrite. If someone have an exponential function, you can rewrite to log. If someone have a log, you can rewrite to exponent. So we can use this method to solve some equations. So I'm going to talk about this in the next video.